Alright, so now let's move on to the second problem here. The description says, we found a brand new type of encryption. Can you break the secret code? Right? Because it is. So here is the encrypted flag and our encryption program new Caesar.py. Let's check the source code to see what's going on here. So the alphabet variable stores the first 16 lowercase letter, that would be A to P. Now we have the flag which is rejected and the key which is also rejected. Then we have two assertion where you can see that the key is located within the alphabet string, which in our case is A to P, and the key length is of course 1, as you can see, and we know the Caesar cipher key length is always 1. So this function right here is doing the Caesar shift. Okay, but this is not our main concern. As we know, the key is only between A to P, so we can easily attack the Caesar cipher by brute forcing it. The main problem here is our this P16 encode function. So we need to reverse engineer this function and brute force the decoded text in order to decrypt the flag. Now let's go through the encode function. At first we need to change the flag to A and the key to A for doing simple operations so that we can calculate it simply. Okay, so now let's run the code. Okay, so we need to print the binary here to see what's going on, and print the encrypted flag. So this is our binary. Okay, so what is doing here is splitting the binary into two substrings. The first substring is 0110 and the second substring is 0001. So the value of this is 97 in decimal, which is the ASCII value of lowercase a, which is our flag in this case, and the value of 1001 is 1110 is 6, and for this one it is 1. Now the value of index 6 of the alphabet string is G, and the index 1 value of alphabet is B. So that's how we're getting the GB thing here. So what we're basically doing is encoding the flag with B16 encode function and then shifting the encoded flag with Caesar shifting to get the encrypted flag. So for decrypting the flag, we need to reverse the process, which is we need to take the encrypted flag and shift it with Caesar cipher using the key that that the alphabet string has, which is A to P in our case, and we need to decode it using a B16 decode function, then we can get the decrypted flag. So I have already written the decryption program, which is below. So at first we need our encrypted flag, which is this one here. Copy it and paste it here. Okay, done. Then what we are doing here is brute forcing with all the key, which is A to P in our case, and lastly decoding it with our B16 decoder function. So let's move on to the decode function and see what we're doing here. The decode function here is taking the two characters. You can see we are starting from 0 and taking two characters of the encrypted text and converting their binary, concatenating their binary and converting them into a single character. Because we saw previously that in the encode function we are concatenating two single characters from one binary. Yes, we splitted the binary into two substring and converted into two characters. So what are we doing here in the decode function is doing the exact opposite. We are concatenating the two binary to create a single character. Now let's run this code here, comment out all this. So out of all the text, only this one makes sense here. Now let's submit it in the PicoCTF to see if it was the flag. So yeah, it was the flag that we are looking for.